Welcome back to the Data Analyst, where we simplify statistical concept for your success. Today we are diving into the fascinating world of the runs test. This is an essential tool in non-parametric statistics, and by the end of this video you will know when and how to use it, its limitation, and how to perform it using Minitab. So what exactly is the runs test? The runs test is a non-parametric test used to check whether a sequence of data is random. It's particularly useful when you have a binary sequence or a series of categorized data and want to test for randomness in their order. For instance, if you toss a coin multiple times and get a sequence like head, head, tail, head, tail, tail, head, you might wonder, is this sequence random or not? That's where the runs test comes in. Like any statistical test, the runs test begin with hypotheses. Here's how they look. Null hypothesis, the sequence is random. Alternative hypothesis, the sequence is not random. So when should use the runs test? Quality control, to check if defects in production line occur randomly. Financial market, to test if stock price changes are random. Clinical trial, to analyze treatment responses across groups for randomness. Essentially, anytime you suspect pattern or non-random behavior in a sequence, the runs test can help. Like any test, the runs test has its weaknesses. Binary requirement. It's work best for binary or categorical data, limiting its application for continuous data. Sensitivity. The test is sensitive to small sample sizes, which can lead to less reliable results. Randomness scope. It only tests for randomness in order, not other aspects like independence. Remember, it is important to understand these limitations before applying the test. Let's see how to perform the runs test using Minitab. So this is our data set for today's session, and then you have to go stat and then click non-parametric and then runs test. And here we have variable box and put our outcome variable into variable box and click above and below the means and click OK. So here's our output results for today's session. So our output results came as p-value equal to 0. That means our p-value is less than 0.05. That means we can reject our null hypothesis. We can conclude that our data is not random.